Okay, welcome to the new channel. This is probably going to be the first video on this channel because this box is going to be retired very soon. So I'm free to make a video on it without spoiling it for everyone who's still trying to attack it. So yeah, this is going to be expiring in about 1 day. So we're going to go through this and I'll explain exactly how to get the user flag and the root flag. I'm probably going to split this into 2 separate videos because there's quite a lot that I want to cover, which brings me on to the next point. This is not going to be just a quick sort of type this, click that, and then you've got the user flag, here's the root flag. This is more of an in-depth explanation of the technical aspects for people who want to learn things. So if you just want a quick cheat sheet for how to get user and get root, it's probably not the video for you. So as always, the first thing we're going to do is an nmap scan. And we need to get the IP address of this machine, so it's 158. And we're going to do the first 6,000 ports because they're generally the most useful. And we want to do T4 to make it slightly faster. And I'll do -V just to get the verbose output so that we can actually see what's going on. So we can see straight away it's found quite a few interesting ports. And to be honest, that is all of the ports that we're going to find. So there you go. But that's one thing I should explain as well, is that I've actually already got user and root. So I'm not going through this for the first time, so you don't have to watch me struggle. But yeah, like I say, I'll explain how and why I'm doing things on the way. So a few interesting ports here. We've got port 21, which is FTP, which is almost certainly going to be something we can exploit in some way. Spoiler alert, we don't end up using that until the root section, so that's not going to be useful for now. But if we try to get into that now, we just get access denied, basically, because we haven't got any credentials. Port 80, so there's a web server running on this thing, so let's have a look at that. Now weirdly, with this server, it kind of loads into a dashboard and then kicks you out into the logon screen, which at first I thought was something we were supposed to exploit, but doesn't seem to be the case. Now this part here is a bit of a guessing game, which I'm never a fan of on machines, but in this case it was very easy. It was just admin and admin, if I remember rightly. That's like one of the first credentials I would always try, is admin and admin, or administrator and administrator, or admin and password. So yeah, I kind of don't like when you've got to guess things, but in this case it was extremely obvious. It was like the first thing I ever tried, so it's not too bad. And if we can have a look around here, but we don't actually find anything interesting. I had a look through all the source code and everything, and didn't see anything useful. But what we can see, if I press F12, then we get the Chrome developer tools up, and if we reload this page, you notice that when we log in, one of the things that gets queried is this account page or folder in here. And if we click on that, we can see that what's coming back from there is this JSON format data. So if we look at the headers, it's kind of confusing because the actual response that we get back is just this JSON format data, but also in the bearer HTTP header and also in the cookie HTTP header, we have base64 encoded version of this JSON data. For anyone who's not familiar with JSON or doesn't know what I'm talking about when I say JSON format data, JSON is literally just this, just a name and then a value. So just name is username, like that's the property in this JSON file that we're specifying, and the value is admin. The password is that. Now, at first you might think, well, passwords are interesting, that's what we want, but we've already logged in as this admin account, so that is just the MD5 hash or whatever kind of hash it is of the password, which is admin, because we already know that. So this doesn't give us any useful information yet, but the fact that we can see it querying this thing, and that we can see in the HTTP headers this is base64 encoded version of some JSON data, the next thing that kind of leads us to look at is how can we exploit some JSON queries like this. The fact that it's in the HTTP header as we request it means we can control it, we can set whatever we want in here. So is there a way that we can manipulate that to get the server to do something that it shouldn't do when it processes this value? Just real quickly as well, coming back to the other ports that were open, 135 is not really anything we can do with, 139 not anything, 445 is an SMB share, but if we try and go to this server, he'll eventually basically ask me for credentials, so we can't get in there. Yeah, so we can't do anything because we haven't got any credentials yet. Again, you could try some obvious using it as passwords, but I'll tell you now that none of them work. And then the other one is that we've got 5985, which is PowerShell remoting. So if we had credentials, we could do enter-ps session 158, and then we'd specify the credentials here, but we don't have any, so we have to just try it blindly, and it'll just say we don't have access, basically. Actually, I've just realized that the error message we're getting at the moment is not just the general access denied. This is a new VM that I've set up to do these videos from, so I need to set the trusted host thing. I figured I'll just go through that quickly now because it's not particularly intuitive, and you might come up against the same thing if you're using PowerShell. Basically, I just quickly Googled how to add a computer to the trusted hosts, and this will just add all machines to the trusted host. So basically means we can just connect to anything. So we'll paste that in. I'll just right click then and just paste the whole thing in. Paste that in, press Y, and now if we do enter PS session again, we just get the normal access is denied error message. So that's what we want essentially at this point, because now our machine is set up to trust the remote machine. It's just that we don't actually have credentials. So anyway, yeah, coming back to this whole HTTP header thing. What we need to do to actually gain control of these headers, or the easiest way to do it, is to use a tool called Burp Suite. So if we just open this, I'm sure there's plenty of other things that this tool can do, but the only thing I've ever used it for is just for what you're going to see now, where you modify a HTTP request to change a header and then send it back on to the server. Okay, so this is the first thing that we're going to see, and basically the proxy section is what we want to use. I'm going to leave intercept off for now because we're just going to send it to this repeater section so that we can keep sending new requests, but you could just intercept it and send it on, but this will make sense in a second. If we just change our proxy settings so that we're actually using this machine. I've never done this on Windows 10, but yeah, they've just made everything look uglier as they do. So we'll save that, and then now we should be going through this proxy server that Burp Suite has created itself, basically. It probably explains somewhere that it's running on port 8080. I can't remember how I figured that out the first time, but yeah, just trust me, it's running on port 8080 on the local machine. So now, when we go to any website, let's just refresh this, we will see it come through here in the HTTP history section. So again, we're seeing all those things that we saw in Chrome, but the difference is this time we can actually modify them. So eventually we'll see this GET request for the account page. Just move this down a bit. Oh, except we're not, because we've logged in through the proxy, it's complaining. So eventually we should get where it queries the account object. There we go, that took quite a while, but yeah. So now we can see that we've got these headers, and if we do right click on this and do send to repeater, now in this repeater section at the top, we're now free to just modify this and then just send the request over and over again, doing whatever we want just to test things. So we're going to use this bearer HTTP header. You could do it in this section if you wanted, but I'm just going to edit it in here. So we want to take out all of this JSON data, which again, just to explain this is just base64 encoded version of the JSON data that we already saw. So if we go to like a base64 decoder, so we just use this, retype the base64 stuff in there, decode, we get that raw JSON format data. So this is what we're trying to manipulate, this is what we're trying to exploit, and we can do that by using a tool, that's very annoying, isn't it, that VM toolbar? We can do that by using a tool called YSOSerial. I can't remember exactly how I found this, but I think I just Googled like JSON.net exploit or something like that. Also, I think I did see a hint on the forum page about this box that mentioned something starting with a Y. So as soon as I came across this, it kind of rung a bell. So that's kind of cheating, I know, but there's nothing wrong with using the odd little hint and tip. I'm not going to claim that I'm an expert. I'm kind of just winging it through these things, just like most of you guys. So we look at this YSOSerial.net thing, and it basically tells us that we can just run it and tell it to create an exploit package for us, essentially like a payload, and then encode it in base64, which is handy, so we can just send it straight to the server. So if we take their example and we'll go into where I've got the program already downloaded, I just downloaded it from the release tab on the GitHub page. So if you go to releases here, you can download the latest version of this tool. If we go into tools and then into YSOSerial, and then I think we just run the actual executable in there. We do, yes. So if we look down here at some of their examples, we can see that they've got an example here, generate a payload for JSON.net, which is what we want to do. So if we just basically copy and paste that, although they've done it in PowerShell. If we copy and paste that, get rid of the extra thing. Let's just clean this up a bit so you guys can see a bit easier. So basically, what this is doing is just generating some JSON data for us. So JSON, as we've seen, is just strings. It's just a value and then, a name and then a value. So in this case, the name of the value is method name, and then the value is just the string start. And the name of the property is method parameters, and then it's got all this sort of section that's within that method parameters object or property, whatever you want to call it. So this looks a little bit overwhelming when you first see this. You think, oh, this must be doing some crazy, cool, exploity stuff because there's all these numbers and GUIDs and curly braces and stuff. But it's actually pretty simple. I mean, the exploit itself is very clever, but this stuff here is actually pretty simple. I'm going to explain this in depth, so buckle up, I guess, because this might drag on a bit. But I'll try and keep it as brief as I can. But I do want to cover all the technical information. So if we just change this to base 64. That will give us this thing that we can send to the server, but all that's going to do is start calculator. It'll run cmd and it'll pass in /c calc. So let's change it so that it does something that we want. So we'll change it so that instead it runs, let's set up a share on my machine, and then we'll have it run a file from my machine. Okay, I had to do a bit of troubleshooting there because, like I said, this is a fresh VM. Some of the permissions weren't set up right, but I've set the share up now. We've stuck netcat on the share. So we're going to get this to actually run netcat from our share. Now, we have to put a load of extra backslashes basically, because normally you would type a share like this. You'd do server/share/file.exe, whatever, if we wanted it to run that. But because this is going to be in some JSON format, we want to actually do it with double slashes everywhere that there would be a single slash, because the backslash is a special character in JSON. So basically we have to do it like that. So let's transfer that into the actual data that it should be. And then I've called it shared, and then nc.exe is the file that we want to run. Now we also then need to do the port that we're going to listen on, or port that we're going to connect on, sorry, so we'll do 4455, and then we want to tell it to actually execute cmd in the reverse shell. But basically that's what we want to do. We'll change the output to be base 64 instead. And then that gives us this. Now, like I said, I'm going to explain in detail exactly how this works. Like, why does sending this string make the server actually execute something that it shouldn't do? Because in theory, it shouldn't do that. So we'll explain that in a lot of detail once I've just kind of proved that this works. What I actually ended up doing when I was doing this the first time is, because, like I say, you've got to mess around with a lot of speech marks and stuff, and this has got to be enclosed in speech marks anyway because it's an argument for the why so serial thing. Because of all that, I found it easier to just go into Notepad, stick the payload in, and then just type it out manually in here. So we're going to do speech mark, and then the server path. So again, my machine, share, nc, and this is all just the exact same stuff that we just did. But we've got extra control over where exactly the speech marks go, because it's not just all been passed in as one thing as part of the arguments to this program, and then this is going to be passed in and be arguments to this, and then JSON's escaping special characters, and it just got really messy. So we'll try it like that. I'm also going to stick a backslash in front of the two speech marks because I believe they are treated as special characters in JSON as well, so we need to escape them. So now if we take this and we stick it in a base 64 encoder, which you can see I've already done before when I was testing this, and we encode it, and then we run this. Oh, I've just realized that I didn't put the IP address in, that we're going to connect to. I always forget some arguments when I'm doing netcat stuff, because you have to put the IP address and then the IP address again and then the port. So let's do that and see if this works for us. So we'll send that to the server again in this bearer HTTP header and see if we get a connection. So we're listening on 445. Let's send and see. Yeah, so now we actually get a connection. So if we do who am I, we can see that we're now running on this JSON box as the user named user pool. Let's just see if we can actually get anything like the flag or anything like that. User pool, desktop, and we do indeed see the user flag. So we just do type user text. So there we go, that's the user flag. But like I say, I want to spend most of this video kind of talking about exactly how and why this works. Like, why does sending that to the server make it run the program that we want, when all it's expecting is just some JSON format data. So to do this, we're going to have to go quite in depth, and we're going to create a new Visual Studio project just to kind of demonstrate this. We'll just do a WPF app, and you'll see why it needs to be a WPF app in a second. There we go, we'll call it whatever. Okay, so we've got a WPF window. Let's just quickly create a button. And we'll just say click me, and we'll stick it in the middle of the screen. There we go. So now when we click on that button, we want to execute some code. And what we're going to do is simulate exactly what WhySoSerial was doing. So this is just some JSON data, like we said, and the server is expecting some JSON data, but not in this format. Now the reason this works is because the server is set up in a way that allows JSON data to specify what type of .NET object it should get converted back into. Don't worry if that doesn't make any sense, I'm going to demonstrate this. I should point out as well that this is not the default setup for JSON.NET, so you'd have to get pretty lucky out in the wild for someone to have set it in this bad way so that you could exploit it, because it's quite a specific sort of scenario where this exploit will actually work. But it's interesting for like HackTheBox machines and CTFs and stuff like that. So let's say in a .NET project you had the server that had some class that was, let's say, ID as an integer, and we'll do name as a string. Okay, so it's got this class called person. Okay, and the server is expecting. Let's use the example that we had here. There we go. Yeah. So username of admin and ID of 1. So let's just do username, and then you kind of get the idea. So the server is going to try and convert this JSON data back into an instance of its own class that might look something like this. Okay, so it receives some data in, and the .NET code running on the server tries to basically say, here's this JSON data that looks, it's just a string. Take each of the properties that we see in here. So take the ID value and put that in the ID properties. Take the username value and put that in the username property of this person class. The way that we're exploiting it though is we're not actually going to send it a person class instance. Instead, we're sending it a string here that starts with $type, which means we get to specify what class this is all going to be treated as. So now it's not going to be treated as this person class at all when the server receives it, which is why we get that error. So we saw in here, we get an error has occurred, unable to cast object of type blah blah blah, which is the one that we specified, to type JSON.JObject. So that's what it's trying to convert it into, is a JObject. That kind of, yeah, it's kind of backwards to how I've explained it here, because you're only seeing the JSON side of it, which then after that it will then try and convert it into this, like this called person class that we're calling it here. So just kind of assume that this, or just pretend that this here is saying person, basically, for our example here. So again, just to recap, we've got JSON data coming in that's trying to be converted to this, but what we're actually sending it instead is we're saying, no, don't convert it to a person, convert it to this. And this is why I've made this a WPF application, because this particular class is part of the WPF framework, the presentation framework in .NET. And again, don't worry if this doesn't make sense to you. I'm going to demonstrate it, and hopefully it will by the end. So what are we actually doing here? What's actually happening when the server receives this data? Essentially, we are creating a new one of these, so a new system.data blah 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 object provider. So let's just do that now. So we're going to simulate what the server's doing as it receives all this JSON data, basically. So it's going to create a new instance of that class, okay? This object data provider class. It's going to then set the method name property on it. So method name is going to be start, because that's what we're specifying there. And then in the method parameters property, parameters, we're going to add, here it's adding a collection. So again, we can see this type, we're adding a collection array list, but we're just going to add them individually. So it's adding two values here. It's adding CMD as one value, and then it's adding this as the second value. So let's just do CMD, and then we just do that again to add the second value. But I'm just going to leave that as this for now so that you can just see a visual demonstration when I run it. So that's all this bit taken care of. And then it's going to set this object instance property to a new process. Just to make it clear, actually, I'll do system diagnostics of process. Okay, so because that's what we're doing here. Okay, we're just saying this object instance property gets set to a new thing that is of type system.diagnostics of process. Okay, so that's all that's doing. That's all the server's done, is it has passed that JSON data into this. This code essentially is going to run on the server. Now, if you're familiar with programming, you would look at that and say, well, so what? That's not going to actually do anything. Like, you just created an instance of a class, set some properties on it. You haven't called any functions. We haven't done like call initial load, which according to the IntelliSense thing, that starts the initial query to the underlying data model, which would actually trigger these things to get evaluated. And we haven't done that. We haven't done anything. So we're just going to run that. Okay, when I click this button, we're going to simulate what the server does when it receives the JSON data. What you'd expect to happen is nothing, because again, it's just created an object, set some properties. You'd expect it to just go straight to this error, and that's it. But if the exploit works, then what will actually happen is CMD will pop up. So let's see what happens. So we've got a program here, and we click on the button, and command prompt appears. So why on earth has command prompt appeared when we didn't actually call any functions? Because again, in the JSON data, because you might be thinking, why don't we just, in the JSON data, just pass in process? Like in this JSON data that we're sending to the server, why do we bother with this whole object data provider thing? Why don't we just do process? Because that's what we actually want to get to. What we're essentially trying to achieve is calling this function on the server, okay? So all this stuff here, why is it complaining? What was wrong with that? Whatever. I don't know why that's... Oh, because this program's running. Sorry. So what we're simulating here is just calling that. We're just calling process.start and then passing in CMD. Okay? Again, here, so we're specifying process here, start, and passing in CMD. That's all we're trying to do on the server. So why don't we just do that directly? Why do we need to bother with this whole object data provider thing and method name and method parameters? Basically because all we can set in JSON is properties. Okay, we can't call functions. We can't call process.start because that is a function. See that function? All we can set is properties because JSON is supposed to just be for data. It's not supposed to be code. Like, again, we're exploiting it to make it run code. All it's supposed to do is receive stuff like we received here, or send stuff like this, where it's just a username, a string, password, a string, name, a string, ID, an integer. I mean, it's not supposed to be telling it to execute any code. It's just saying, here's a property, here's some data that goes in that property. The way this works, and it's very clever, the fact that whysoserial.net people have figured this out, this object data provider class, basically it's supposed to be used in WPF applications like this, where you might have a table in here that might have a load of data that's been pulled from a database or from a file or from whatever. It could be pulled from anywhere. You can use this class to basically call any function in the .NET framework. So in our case, we're calling process.start. When the data binding needs to be updated. So say when the window opens or when the user clicks a different record in the table, it might need to go and call some function on another process or on another class, sorry, and get some data that way. So it's just kind of a handy class that Microsoft added just to give you a lot of flexibility with updating data bindings in WPF. And again, you don't really need to understand that side of it. All you need to understand is that when you set this property, this object instance property, it actually triggers the reload or refresh method. So this refresh function here, which again would, if you're actually calling a function, you expect something to happen. But just setting properties, you don't really expect anything to actually happen. But in the background, when you set this property, it actually calls the refresh function, which then causes whatever you've set in here, whatever method name and whatever class and whatever parameters, causes them to all be evaluated, which in this case means we actually start a new process. So that is what is happening. Now, to be completely fair, if you wanted to actually completely mimic process.start, instead of doing object instance and a new process, you would actually do object type and do get type. And I don't know why it puts those things around it, because then it stops it working. Get type process. Okay, so now this code here is completely mimicking just process.start, calling a static or shared function on the process class. But again, if we run this, we comment out the actual bit that should be starting it. Again, we get the same thing where when you set the object type property, it triggers a reload. So when this thing eventually opens, and we click on it, we still get command prompt appearing. So even though we didn't set that object instance property, setting object type does the same thing. So it's, to be honest, I think it's a pretty terrible design from Microsoft with the .NET framework, having it where you set a property and it actually calls a function that can do literally anything. Like, again, here we're using it to just do process.start. You could use it to do absolutely anything that you can do in the .NET framework. So it's because it lets you just specify a function name and pass in whatever arguments you want on any class. So it's ripe for exploit. And like I say, the people who made whysoserial.net, they managed to figure out that you could use this with JSON data And I mentioned at the start that it's kind of a very specific, poor setup that allows this to happen. And the reason that is because normally in JSON.NET, you can't specify what type of data is going to be in the JSON file. So normally you put this and it'll just error out straight away before processing any of the rest of it. So yeah, you do have to set a specific property on your JSON.NET formatter in the server-side code to allow this to happen. Now there are some legitimate reasons why you would want to do that, so it's not completely impossible that someone would do this, but it's going to be pretty rare and it's not the default setup. So anyway, I hope that explains it. And again, don't worry if you don't understand WPF data binding or anything like that. All you need to know is that setting properties actually triggers a function to be executed, and this class in particular allows you to execute any function with any arguments on any class in the .NET framework. So that's what happens. Instead of it being converted into the person class or whatever the server is expecting the data to be in, it runs all this and then it errors out, because once it's done all this, it's now built the object that it got from the JSON data, and now it'll try and cast it to what the type of object it's actually expecting. So now it'll try and treat that data as a person object, or in our case it was like a J object, wasn't it, in here. So it'll try and treat it as a JSON.link.j object, and then it'll fail. So, but it doesn't matter, because at that point it's already hit this, which has then actually triggered our process being started. So that is how we ended up with a shell on here, which has died. So if we send that again, we will get another shell come through. So yeah, we get another shell and we can look around and do whatever we want. So that's how we get to that point. I think we'll end this video here because this has been pretty damn long, but hopefully you've learned a thing or two. And yeah, we'll do another section or part 2 very soon with the root flag.